So we're going to derive the derivative of the quotient rule. So if I was given the function u divided by v, where u and v are functions of x, so u is going to be a function of x. That just means that it will have the letter x in it. V is also a function of x, just a different function. And maybe that's g of x. So when I divide these two functions, the question is, I wonder what the derivative with respect to x of this quotient rule is. Sometimes people think it's just the derivative of the top over the derivative of the bottom. So what would happen here is if I was to graph this function, we know it would be some rational function with a vertical asymptote at 2/3. And I got that from just looking at the denominator. I would also have a horizontal asymptote. It looks like, let's see, 2 bigs over 3 bigs is about 2/3 again. So it's right there. So that would mean the slope is always 2/3. Well, I can tell the slope here is steeper and it's negative versus the slope at this point. So I don't think 2/3 is going to be how we find the derivative. So we're going to have to go through a proof of that. So recall again, the quotient is just a division problem where u and v are functions of x. I'm looking for dy dx, which is also the limit as the change in x goes to 0 of the change in y over the change in x. So it's that average rate of change. As the 2 points come together, it's the instantaneous rate of change. So that's kind of the format I need it in. So if I'm looking at my original problem, I've got a problem. I don't even have a change in y. So we're going to take and we're going to add some change in y. Some change in y will result in a change in u and some different change in v. Make sure that you have your u's and your v's distinguishable. So that's going to be the result. Well, okay, I've got a change in y. I really don't want the y, but I now know what that is because I've defined it earlier. So y is equal to u over v. To get rid of it, I'm going to subtract, and I have the change in y equals u plus change in u over v plus change in v. And then I have this minus u over v, because that's what I was doing. So I'm going to put that minus u over v, kind of line it up here, minus u over v. So now what I'm wanting to do is subtract those. I like that I have a change in y. I'm thinking if I could just simplify the right-hand side a little bit by getting a common denominator. This fraction is missing the v plus delta v. So I'm going to multiply by 1. So we've done that a lot, and we've talked about, like, man, that 1 is pretty important. In this fraction, it looks like I just need to multiply by a v. So now I have a common denominator. So my denominators of v times v plus delta v. Looks like my numerator is v times u plus, so I'm just distributing here, plus v times delta u minus u times v minus u times delta v. So, my u, v, and vu will cancel. Looks like it got cleaned up a little bit there. I'm going to kind of put my parenthesis there. So again, if you recall what I'm looking for the limit of the change in y over the change in x. I've got change in y. I'm going to divide this side by the change in x. So that means I'm going to divide this side by the change in x. So what's that going to produce? So I've got change in y over change in x. That's well on its way to becoming a derivative. I'm going to divide everything here by change in x. So this change in x gets divided by each term here, and that's going to be over change in x. And let's see what's going to happen. I still have my denominator here, which is v times v plus delta v. So looks like I've applied the change in x to my terms that are remaining. If I now put a limit out in front of this, I now have a derivative on the left. That's what I was looking for, but I can't just do that. I believe I have to put a limit on this entire other side as a change in x goes to 0. So let's rewrite this. So this piece right here, by definition, is dy dx. So I've got what I want. Make sure you understand that that's a y and not a u. Let me just rewrite that. Change in y over change in x. Now I'm going to apply individually this idea of a limit. So I'm going to have the limit as the change in x heads towards 0 of v delta u over delta x minus the limit as the change in x heads towards 0 of u change in v over change in x. And I can't forget that this whole thing is divided by the limit as the change in x heads towards 0 of v squared plus v delta v. There is no change in x because that got divided by each term up here. This term went away. This term was divided by change in x, and this term was divided by change in x. So let's see what happens and dissect this down into each little component here. V doesn't have any change in x's in it. It's just simply v. As delta x goes to 0, delta u over delta x is now du dx by definition of a derivative. Change in u over change in x, change in y over change in x as the change in x goes to 0, minus this is u. Change in v over change in x is dv over dx. Remember, v is in the denominator, u is in the numerator of my original function, u over v, which was my quotient I was trying to take the derivative of. So let me get that to write up here, which is u over v. This is all divided by, well, v squared has no change of x in it. And if I know the change in x is going to 0, this piece is actually going to go to 0. 0 times v is 0. So this is now the derivative of the quotient u over v. So let's rewrite that so we can see. So we started with y equals u over v, where u and v are functions of x. And I now know dy over dx is equal to, and again that's a y not a u, is equal to, according to what I just wrote down, it was v du dx minus u dv dx all over v squared. For the sake of what's coming your way in terms of derivatives and kind of remembering this, I always say the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Notice these v's. So it means the same thing. I have just shortcut the idea of this derivative and called it du, this derivative dv, and I've left it in that form, which is a little bit different, but it's just a multiplication, so it's just your commutative property. So I always say the derivative of the top. And what do I mean by the top? U is in the top, v is in the bottom, so I call this the top. I should be calling it a numerator, but for the sake of kind of, I hate to call it like a chant kind of thing, but it helps me remember the derivative of the top du times the bottom, v, minus the top, u times the derivative of the bottom, dv, over the denominator squared. So what we'll do is a couple practice problems together on this.